So we were just looking at how how to structure, um, a list, and what we have here is we've got an attack that is variable. So we've got a message variable here that is um, between 0 and 1 um, that scales with our MIDI velocity. So um, the harder we play a key, the higher the amplitude of the attack of our envelope is. And then when we release the key, we get a 0, select 0. This does a bang that starts a 1-second release here. So what we want to do is say, hey, what if we wanted a decay that was some value that we can guarantee is less than this variable? To do that, we need another variable. So we do $2 $2 for the second variable. And let's say we wanted to decay to whatever this value is in 100 milliseconds. And we want to delay that by 50 milliseconds because our attack takes 50 milliseconds. Okay, so but we still actually only have one value here. So what we want to do is pack a list. So if we send a list to a message box, it's going to take the first element of that list and put it wherever there's a $1. It's going to take the second element of that list and put it wherever there's a $2, and so on if we had more along our list. So, we could make all of these variables if we wanted to and, combine different values in a list, but what I'm going to look at is just how do we have a variable that is guaranteed to be less than this variable. So we know we're going to need a pack, and pack creates lists. So it takes some values and combines them into a list. So by default, we have 2 inlets, but let's say we wanted to be able to have 5 different floats. We could say pack 5 floats, and F is for floats. We could pack symbols, like the name of, say, a table or a send could count as a symbol. We could pack those into a list. If we specify that, hey, we want symbols here, we couldn't use floats, and what we want to use is floats. So if we leave it blank, we can use anything, or we can specifically say, anything. So A is for anything. We can pack other lists, so we can pack multiple lists. Use L as the abbreviation for list. But we don't really need to worry about it if we're only packing 2 elements, and we know that we're only putting numbers here. We don't really need to worry about it unless we're making a list that's longer than 2 values. So now we've got what we want here in terms of how to create the list. We still don't have the actual value yet, so we still only have this one value. So we know we want this to be this value. So we're going to play a MIDI note, divide the velocity we get by 127, and make that the destination value for our attack. And so that's going to be the first element of our list, is $1. If we put $2 here and $1 there, that attack value would be in this position. So we can put $1 anywhere. The first element of the list is going to go to that position. of the message. So ultimately we're going to want a list coming here with 2 elements. So what should this element be? We can say, hey, if we divide by something more than 127, that's going to be a lower number than this number divided by 127. So I'm going to divide by 254. But any divisor that's greater than this one is going to output a value that is less than the value that this one outputs. So I can say, just do that. So now I have, when I play a note, I'm generating one value and I'm dividing it by 2 different things. I'm packing those into a list together. First value would go there, second value would go there. But there is one more issue to deal with, and that is pack works like most of the objects that we look at, in that when it receives a value in the hot inlet, it outputs its entire output. So if we play a note and it divides by 127, and that gets sent to pack, even if we've not received this value to the cold inlet yet, it's going to output to our list. So we might not get exactly what we expect. And the way we handle that is, instead of just splitting 2 outputs from a single outlet like this, what we would do is use a trigger. And the trigger object will say T, short for trigger, and then we're dealing with floats. So say we want to output 2 floats from a single outlet. So here's the input to the trigger. Instead of outputting 2 directly from the outlet, we output 1 to the trigger, and then that same output comes from both of these inlets, with the special difference here being that it guarantees that the right outlet is set first and then the left one, so that when we get to this pack, we set the cold inlet and then the hot inlet, and then output the list with both of the values that we intended. That's it. So now we can set multiple parameters in a single message box here. And I'll bring this down to show that these are corresponding. So either when we hold play the note, we generate an attack ramp and a decay, and while we hold the note, it's sustaining, and then when we let the note go, that's when our release starts. So this is the basic structure of MIDI velocity and MIDI notes. Keeping in mind that it might look different if you have a V line for each and every partial. You'd have to restructure that to accommodate for that.